another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on some specific input and output devices. There are 4 specialist devices you need to understand the working of in the AQA specification. These are a barcode reader, digital camera, laser printer, and RFID. Barcodes can be split into 2 basic types: linear barcodes, also known as 1D barcodes, and QR codes, also known as 2D barcodes. There are fixed and handheld scanners for barcodes. These can also be read by CCD readers and camera-based readers. However, QR codes can only be read by CCD readers and camera-based readers. The pen-style barcode reader needs to physically touch the barcode. It uses a light source and a photodiode placed next to each other in the end of the pen. As the pen is dragged across the barcode, it detects the level of light reflected back. The black sections absorb light and the white sections reflect it, allowing the scanner to detect the width of the barcode stripes. The laser barcode scanners found in most supermarkets use mirrors and lasers to enable barcodes to be read at more angles. They work in essentially the same way as our pen device by detecting the light and dark areas. CCD handheld devices use an array of sensors that measure the intensity of light that allows them to reproduce the barcode data as binary information. Because they are handheld and can be wireless, CCD devices can be useful to reach the barcode on unusually shaped or large objects that you couldn't put through, say, the normal laser scanner at a supermarket checkout. Camera-based readers use a camera and interpret the image using image processing methods. Some CCD readers can also read 2D style barcodes. This also allows for codes to be read from screens. The images can also be scanned at any rotation and at varying distances from the camera. A digital camera has a CCD or a CMOS sensor that captures millions of points of light using sensors arranged in a grid. Each sensor measures the amount of light and records it as an electronic value. By doing this with a red, green and blue biomosaic filter, they can get 3 readings for red, green and blue that can be combined to reproduce a colour. So when you take a picture with a digital camera, the image passes through the biofilter onto the CCD sensor, where it's able to get a value for red, green and blue. This information is converted from analog to digital, and then it's stored on your computer, either as a raw image or it's further processed using an algorithm that applies things such as fill light and contrast to be able to create something like a JPEG image. To print a page using a laser printer, first, the printer creates a bitmap image of the page that needs to be printed. The drum is given a negative charge. A laser light is bounced off a mirror to create a negative reversed image of the bitmap, which effectively removes the charge from those sections of the page. The page rolls over a roller covered in toner, which is positively charged, so it sticks to the areas that retain a negative charge. The paper then passes through a fuser roller, which seals the ink to the page using heat and pressure. In a colour laser printer, this process takes place 4 times for each of the separate toner colours. RFID stands for Radio Frequency Identification. RFID tags can be used in similar ways to barcodes, but can be read without needing to be in the line of sight of the reader and from a distance. RFID tags are used for a variety of purposes, such as pet microchips, product tracking, automatic toll gates, and contactless payment. This library RFID management system example shows how useful RFID tags can be. The library puts tags in their books, then they're able to quickly check them in and out. They're also able to have a self-check-in and check-out machine. They're able to detect if people are trying to take the books out of the library without having borrowed them. and they're able to have a book drop that's automatically able to detect what books have been put back in. They're even able to use tags on the shelves to check whether books have been put back in the wrong place and help keep their shelves in good order. An RFID system consists of a tiny radio transponder, a radio receiver, and a transmitter. Active RFID tags have a power supply that they use to transmit a signal that allows them to work at greater distances. Passive RFID tags do not have a power supply and instead are powered by the radio waves sent out by the reader when they're close enough to receive them. This makes passive RFID tags much cheaper to manufacture, as well as being able to be very small. That brings us to the end of this video on input and output devices and this series on computer organisation and architecture. Join me again soon when I'll be back with videos on the theory of computation. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.